Cool. I'm live. Come on. Come on now. Okay.
Yeah, I mean, you gotta do it nice and I ship a lot, so I'm always making my own boxes, my exacto name. Let them go to boxes that are fun. They look like Frankenstein, but they're pretty strong.
Alright. Sorry. Technical difficulties here. Still trying to figure this out. Oh, I forgot to restart SDDM because Linux. We are already at 100 megabytes. Alright, poor little laptop here getting that set up. Twitch.tv. Okay. For me, on my live, let's go to my channel here. Hey, alright, I'm gonna say hi to myself. Hi, me. Okay, so now that I am set up here, I wonder what it looks like if I do this. Oh, it's a separate thing. What if I do this? Display. Like to. How do I do this? Primary resolution, rotation. Right, I don't want to extend them. I want them to be mirrored. So how can I do that? Legacy applications. Oh, I need legacy applications. Enabled. What? Dude. How do I change this? Super Shift B. Okay, we're identifying them. We're trying to see. So the primary screen, this one. Be right back. KDE. mirror screen. Mirrorcast extend. How to screen share. This only shows monitor or laptop screen, not both. KDE move app window. Oh my god. I don't want to use a virtual display here. Display configuration is where I was. Get some more settings here. Display and monitor. Multimedia. Alright, turn that off. Go in black. Yoink it. Settings are reloaded. And the new output. Well, how do I get that output? Dude, what the heck? Device enabled. Key. KDE Connect. Holy crap. This is not very interesting. Sorry about that. Don't care about my recap on Twitch. Tell my friends all about this. Oh yeah, crunchy. Degraded and unavailable servers. That's cool. Might see errors starting a video stream. How do I get this to work? There it is. Okay, cool. Found the settings that I wanted. Duplicate. Woohoo! Alright. Duplicated. And not working that well. Interesting. Woo! Cool. How cool is that? Let's see. What am I doing? Stream manager. I'm streaming right now. Just chatting. Okay, cool. I can see some stuff going on here. We got activities, we got chat. Oh, right on. Hey, I want to offer promotion of my channel. Oh. No thanks. I don't want to go to streamrise.ru. That doesn't sound like something I want to do at the moment, but thanks. Get out of here. Get out of here. Alrighty. Still trying to figure all this stuff out. I apologize. I am not the most experienced streamer on here yet. Oh, cool. Quick actions, edit stream info, clip that, raid channel, manage goals, stream together, and other things, I suppose. No recommended changes. Oh, cool. Alright, we got Discord up here. Let me do something over here. Retro computing, PCB design, software, off topic. Being hardware, I suppose. Okay, what can I copy and paste? Copy paste something here from Element. Pardon me. Okay, so we got it in Hackaday, and now let's go to teardowns and exploiteers. Anyone? Aha! At JDuck. Cool. Hey, single rider, what are you doing there? Well, Karina, I have in my possession, switch scenes here and move my camera over. Woo! I have this. I have a, it's a Blink doorbell. And the Blink doorbell, it's a smart doorbell, and it has Wi-Fi and Bluetooth and a camera in it, and it's meant to be something that can show you like who's outside your house and give you essentially surveillance as well as notifications on your phone, things of that nature. But what I'm hoping to do is to take this doorbell, take it apart, and then see if there's any way we can get it to do things it's not designed to do, and see if we can, I don't know, break it and add functionality, see if we can poke inside the guts of it, see if we can, you know, do privilege escalation, all sorts of fun things. So without further ado, I think we're ready to begin. So I'll talk my way through this process here. I got these on Amazon. This was a, well, hold on, let me move this on up. And then move that on down. Haha. Okay, so I got this off of Amazon for like Prime Day or I don't know, something. And so they were heavily discounted because I know that Amazon has had a lot of problems with, I don't know, their different hardware projects, both internal, like Amazon Alexa, as well as external. Things like Blink and Ring, which are both owned by Amazon, as well as Twitch. They are a mega corporation. So going ahead and getting this off here, I already put some I fixed it stickers on here because we all know that I'm going to fix this so good, fix it into oblivion. All right, so it's got this nice little packaging, kind of cool. Shoop. Get rid of that. And easy enough to get into. Getting started with Blink is easy. I don't really care about these instructions. Ooh. Stuck together with adhesive. There's a little thing. Okay, how to mount it. So it looks like there's some screws back here, these little protective things, protective pieces of plastic. Woo. Oh, by the way, chat. Well, I say chat, but really, single rider. Does the audio sound okay coming through on the stream here? We shall see his answer in a moment. I'm still trying to figure out just the whole streaming setup and how to do this properly and effectively. wow, this sucks. I hate it already. I'm trying to get this like plastic material off, and it is being quite persnickety. Okay. That's coming off. And so this is saying that there's some ways to attach it to your door. Because one of the, I guess, security considerations for a doorbell like this is it's going to be exposed, obviously, to the outside world. And if somebody has, nefarious intentions, you don't necessarily want, somebody to get physical access to your device, because a lot of the time, physical access means you are more or less screwed. It's very easy for a lot of situations to get into the hardware. When you have it on hand and can connect it to a debugger or something like that, which we'll get into in a bit. So Single Rider says, "Are you at a hackerspace?" Yes. So I'm at Circuit Launch right now, and actually I'll show you. Go ahead and pan out. This is my area that I'm in here, and so this we're looking out at like the main manufacturing and like hacking area. There's a whole bunch of like 3D printers and stuff, and forgive the blinding light here, but this is a dedicated like what do you call it, podcasting space, and it's truly a massive facility with a whole lot going on, and super interesting people, a bunch of people working on cool projects. So a great spot to be with a lot of awesome resources, and it's here in Oakland. Single Rider used to work at August Home, the Ring competitor. Autofocus on the FPV perspective is fighting. Yeah, hopefully I won't have to move it around too much, and it'll be a little bit more reliable there. But yeah, it's not the best camera, this FPV thing. So just to show, we have some hardware here. This is for like mounting into different types of materials. These things, you stick them into a hole and then you put the screw in. They expand. This is a little template that they provide, where to drill holes and how to mount it. These things, I think these little metal things, I think they go here and here. And so those little wires will allow you to connect it up to your existing like doorbell infrastructure, so you can like ring something, or maybe that's for getting power. I don't know. Single Rider, do you know if anybody owns August Home, or if it's if they are their own, are they their own company, or are they like a subsidiary of something? Because it seems like a lot of these like IoT smart home companies, they seem to be I don't know, all getting swallowed up. A bunch of folks trying to like corner that sector. All right, so it looks like this part will like go against the door. Kind of scoot it out here a little bit. So this part's going to go against the door, and we've got this fun little tool here that you can like, I don't know, stick it in there, and I guess this is used to like push up on that thing. Can put some lithium batteries in here if you don't have access to any sort of like wall power. Ooh, and here's something very interesting for our purposes. So I'm going to go ahead and bring this a little bit closer. Forgive the autofocus. I'll try to get this to do its thing. But if you see here, I don't even know if you can see here. There, I'll tilt it a little bit. So over here on the right side, point with this little thing. So these are some test points. And these test points are often how the device gets programmed. So in this case, they would assemble the entire unit and mount this on some sort of spring-loaded test fixture, and then from that, you would put the code onto the device, or you'd run through some sort of like full integration test. What single rider say here? Haven't checked who owns them in a while, but when I was there, it was its own thing. First week, hacked an unused pin, connected it to a transistor, and unlocked the door. Oh, with your hand chip, that's awesome. So I don't think they're 18650s, yeah, like you were saying. Some 1.5 volt lithium. Some sort of looks like a AA form factor, but has to be rechargeable. Okay, so here's what we're gonna do before we actually dig into taking this thing apart and unscrewing it and getting into the guts. One of the most interesting things about wireless devices is that, oh cool, they actually come with batteries here. Here, I'll show you. Oh, the PN 532, it's Adafruit NFC reader writer. Sorry, my mistake there. So you were saying that it allows you to open your door with your NFC reader because you have an NFC chip in your hand. That's pretty cool. All right, yeah, so these are like little Energizer AA thingies. So nice that they include them. And they're not even like Amazon Basics. They're like the good stuff. So, if you look over here, I don't know what that QR code's for. I'm going to scan that with my phone real quick. So, I think it is, okay, so that says here, it's not any URL or anything like that. Looks like it's serial number. Yeah, the G8V1T, so on and so forth. It's the DSN, the digital serial number. I don't know. But that would allow you to basically scan it really quickly as you're moving it over like an optical sensor before you put it on your programming and or test fixture. I imagine that's how something like this is used. Right, but I was saying about wireless devices. You can see here there's a couple bits of information that it includes just here in the on the sticker. The MAC address is used for, it's basically the hardware ID to find the device on a network. A lot of the time, these things are spoofable. And so if something is looking just for a device with a particular MAC address, you could clone this MAC address and parade around as a, pretending to be a doorbell essentially. So that is a potential security consideration. Having a more sophisticated key, authorization and authentication mechanism would be much more robust with respect to security. IoT was a mistake. Yeah, I think IoT IoT was inevitable. I think everybody loves cheap stuff, and it was only a matter of time before cheap stuff got connected to the internet. And so nobody really, put the time and energy into making sure that this, cheap consumer electronic stuff was, properly secured. So a lot of the time it's quite a security nightmare, which I'm hoping this is, because it'll make it for an interesting stream. Yes, cheap electronics, a major plot point in Necromancer. Oh yeah, the cheap electronics, yes, but not the Ona Sendai Cyberspace 9. That is top of the line. Got to get me one of them cyber decks. Another point in this sticker, you see this thing here, the FCC ID. So as part of the regulatory compliance process in America, you have to basically assure the United States government that any intentional radiators, which is if it has a wireless radio connecting to Wi-Fi or Bluetooth, you got to make sure that it's not going to disrupt or jam or interfere with other types of devices. And it also has to pass what's called an unintentional radiator. So the way that the way you think about that is if you have energy traveling on a copper trace in a printed circuit board, if you have a high-speed signal, for example, something a couple tens of megahertz or hundreds of megahertz, like a fast SPI device or like a piece of DDR RAM, those will toggle, digital high to digital low really, really quickly. And if you don't design those traces correctly, those can become antennas. So you can have power moving through this wire or through this trace, and that will cause energy to be released, and that can cause interference and a bunch of other issues. So the reason I bring this up is because as part of the FCC certification process, you have to document the board that is going to be under test. And so if we take this FCC ID, we can look it up in a database that will essentially provide for us a pre-torn down high-resolution board photo, so that we can see what chips are on it, we can see the approximate layout, and we can start collecting data sheets and things of that nature. So I'm going to go ahead and switch scenes here. All right, look at that. So if we go to, I think it's fcc.io. Yeah. All right. So if we put in our FCC ID, which is in this case 2 Alpha Foxtrot. Can't read this thing. Hold on. 2 Alpha Foxtrot 77 dash Hotel 2 111 705. Forwarding query to the FCC. And what do you know? Application. So this company here, Imedia Semiconductor, out of North Reading, Massachusetts, they are probably the ones that designed the board that goes into this, goes into the Blink. So I'm going to do a quick Google search for them, just for curiosity purposes. But what are these two options here? Both have the same. How are these things different? They have two. Oh, cool. So there's two different radio frequencies here. So this 2412.0 and 246.2.0. This tells you that this is in the 2.4 gigahertz spectrum, and that's likely going to be the Bluetooth and the Wi-Fi, because that's the frequencies where those devices tend to operate. This 902.3 to 927.6. What's really cool about that, that's a, what do you call it? It's an ISM band, so industrial, scientific, and medical. And there's a lot of like home devices that will communicate over these frequencies. I forget which protocols specifically, but if anybody knows, feel free to yell it out in the chat. So we should have the same pictures though. The same display grant? What are these things? Printer friendly version. That's not interesting. Cover letter requesting confidentiality. No. We want to get in here. I'm going to go ahead and embiggen this because this is too small even for me. Test setup photographs. Media. So this shows over here. This is probably the this is like an antenna, and that over there, this is one of the doorbells. And so this is trying to pick up, you have any spurious emissions that can be picked up and shown on this either a spectrum analyzer or an oscilloscope. I'm not totally sure. So showing pictures of the test setup, but I want pictures of the thing. This is inside of what's called an anechoic test chamber. That's what this big old refrigerator thing is on the outside. So it's essentially a Faraday cage. It's very, very electromagnetically quiet inside. And that way you can set up antennas to emit power or to basically read power to see if to see exactly what the device under test is radiating without any worry about like spurious things like Wi-Fi in the room or this laptop over here, that kind of stuff. You mentioned single rider on the chat. I am using OBS. So that screen that you saw earlier was it was just the Twitch interface. I'm still trying to figure out the best way to like manage a stream. I have I have my laptop, and then I have a whole like streaming computer that all of the like video and audio are going into. So it's a bit complicated and cumbersome to move, but it'll get easier as I figure more stuff out. This thing here, I guess they have a big, piece of concrete that they put the devices on and measure everything with. Oh wow. This big piece of concrete, and then this is an antenna outside, spurious radiated emissions, so it's trying to see like, all right, is this broadcasting anything that it shouldn't, and can we pick it up with this crazy antenna out here, out in the woods somewhere. It's kind of cool. Big horn antenna here. All of these like fun spiky bits. This is foam, and that absorbs and prevents reflections of radiation. Just going through. Okay, so that was just pictures of testing. There's user manuals, test measurement reports. I wonder if letter requesting confidentiality, if that's saying like, hey, we need you to not put pictures up or something. The following confidential materials contained in our application: product information documents, test setup photos, internal photos, and external photos. I didn't know that you could do that. I thought you had to have this stuff be public domain. External photographs. Those are cool. Oh, the batteries. Cool. We got some more stickers on here. What about external label? Internal photographs. Yes. Okay. So back cover removed. Internal photographs. Zoom. Enhance. Link over. Okay. So this is the view of basically with the camera facing into the screen, like face down, basically. This is like essentially where the battery compartment would be, and then these are the test points that I was talking about earlier. What's cool here is that there's a whole frickin' ton of test points. That means that we are going to have a lot of easy access to probing things. This over here, this is a big antenna, and generally speaking, the lower the frequency of your radio transmissions, the larger or longer the antenna is going to be. So this is probably the antenna for the 900 megahertz broadcast or so, and then the 2.4 gigahertz antenna. I don't know if it's visible on this particular picture. Maybe on the next one. I can't get any good readings of the microcontroller itself, even at 1000x. So they didn't do a very good job capturing that. Let me see here. 900 megahertz here. Across the pond. 433 megahertz. Actually, it's common here too. It's one of the ISM bands. In America as well as other places. Internal photos are usually the most interesting. Yes, I agree. Without making the FCC mad. Styrofoam. Oh, it's styrofoam, not concrete. That makes a lot more sense. Just for a short time period to prevent leaking product information. Oh, to the competition use media. Very cool. I did not know that. Thanks, Retry Fail. That's good info. Let's see if we can get some more interesting photos. Oh, it's got a speaker in there. Speaker removed. Okay. The board coming out of the enclosure. Let's see battery contacts and stuff. Board's removed from front enclosure. Okay, so this is the board, the flip side. This is the big old button. And that's the hole for the camera. And the microphone. I don't know. Maybe a microphone goes here. I'm trying to see because there's a little hole in the plastic. I wonder where that is. Anyway, I can't read any of the product marking, unfortunately. But can we see? These are probably LEDs to illuminate the button, give it some UI stuff. This thing here, these like 8 leads, something like this generally is reminiscent of a like a memory of some sort. So this could be like flash. I don't know if it has a bunch of pads on the bottom because it looks like there's a bunch of lines going to it over here. So maybe it does, but this might be where our firmware is hanging out. And then this is the application processor, most likely. We've got a power stage over here. I don't know, maybe some power regulation over here with the inductors. Or actually, this could be an RF section. Generally speaking, when you're laying out a printed circuit board, you want to keep the RF components near the edges of your board, essentially as far away from anything that could interfere, with the RF performance. Which is why this 900 megahertz antenna is way over here, just taking up this entire corner. Still looking pretty cool. This, I think, is an IR LED. So the cameras in here, they pick up infrared, because you can have an LED like this and turn it on full blast, and it's not gonna be super noticeable to humans, but it can illuminate a dark target very, very well. So it's good for night vision type stuff. All right, let's keep on moving. Oh, okay, there we go. A smaller antenna. That looks like the 2.4 gigahertz. So you can see this is the impedance matching network. There's inductors and capacitors that will make sure that you don't have, doing impedance matching, you're trying to set up the circuit in such a way that you have maximum transmitted power from your RF power amplifier to your antenna, because you don't want any reflections or any of that coming back, because it means your signal isn't going to be as strong, you're wasting power, and you're probably not going to pass FCC. So we got this thing here. This is like a little mezzanine connector that the other board sits in. Cool. There's a camera apparatus. This plugs into that little mezzanine board. This here. And that is what's going to have the... Okay, so this is the camera, and then this here is, what are they called? PIR sensors, or passive infrared. So this is the kind of thing that you'd have. This is like a motion sensor, and then there's an amplifier circuit that will basically trip if it detects some sort of infrared source moving across the sensor. So it's basically like a big pixel, and it's what you see in motion sensors everywhere. They're very cheap and ubiquitous. There's a lot of capacitors on here, a lot of big ones. I wonder if they do a lot of power regulation on here as well. I wish I could have my chat detached. Pop out chat. Yes, that's what I want. Move this over. Any possibility the IR is wired for COM, not just floodlight? That is a good question, and definitely worth investigating. Let me see real quick if I can dig in here. I don't actually know, but if you go over here, that's the main board thingy. I'm trying to see the other side of that board, the other side of that LED. This is over here. Yeah. Okay. That would be over here. I don't see any... Well, I gotta look at it when I actually take the board apart, but let's kind of go through here and... Oh, interesting. So the way that they do this, so this whole big black thing on top of here, this is just the lens. That is the CMOS sensor. So this is the actual thing that captures the photons that get focused by that lens. And so it looks like it's a little surface mount component that just sits in there. Moving on through, we got some more solid test points. Whole bunch of, this is big old inductor. This is probably a power regulator. Probably a diode over here. And all of these capacitors Yeah, this looks like this is doing most of the power conversion from like I don't know 120 volts wall AC to the low level voltages that this thing needs to function properly. And the mic board is a separate little thing. Cool. Okay, so this is I don't know if it's what does that say? Lotus mic. I don't know if this is I2S or what's the other one? PDM, pulse density modulation. But a lot of times these things are MEMS microphones, and what's cool about them is the way that they function is there's like a hole on the other side of this board. Where here? So there's a little hole here, and then there's a hole in this metal can on the other side. And when you solder this down, the solder creates an airtight seal around here, and so you create this like metal gasket, and that is used to I don't know help the audio performance of it. And then you have over here you have probably power, ground, clock, and some sort of data signal. So this is going to be ground because you can see it's attached here to the rest of the ground plane. These things here, ferrite beads and capacitors, and they're small traces. So these two here are probably the clock and data, and then this one's power. Big thick trace going to essentially just a capacitor and a ferrite bead. So this is all for doing like filtering and improving the audio performance, or at least the signal integrity, so you get like less noise. All right, so that was cool. There's just a lot of good information in here. See, there's also the little button here, and that's like the reset button. Now, I think we can probably start the process of disassembling this thing. I do want to look this up. ISI 1705. Showing Lotus ISI 1705. Yeah, I don't know. I don't see anything that's super relevant here. Okay, cool. Link home. So, Nvidia Semiconductor continues to operate as an independent subsidiary. Interesting. It initially started as Nvidia. It pivoted into consumer electronics company. Oh. Okay. Here's some of the other things that they make. That's pretty cool. Oh, in December 2019, Amazon rolled out patches in response to research citing vulnerabilities in the Blink XT2 security camera system found by vulnerability detection firm Tenable. What did you find, Tenable? You found critical flaws in a different camera. Oh, the 7 vulnerabilities. 2 are critical. Ooh, command injection flaws. So this up here, this is some valuable historical research, I guess. If they found vulnerabilities in another camera by the same company, they might be reusing a bunch of code, and so there could be similar vulnerabilities in the Blink doorbell. Ooh. In a similar kind of discovery, researchers uncovered a flaw in the Ring doorbell. Ring, but not Blink. So this is good in that it shows that, of course, people have, been taking these things apart and doing research on them. But it also means that the lowest hanging fruit could potentially be already picked. Okay. Well, in that case, let's go ahead and start this disassembly process. Let's get into the guts. All right. Ooh, smoky jazz pedal. Twitch audio sounds like it's going through a PA system. Yeah. I'm still trying to figure out acoustics and stuff like that for making the audio sound better. I've seen some videos on like adding filters and doing like noise cancellation and stuff like that. So the more I do this, the better it'll get. But for now, if it's not too distracting, we'll just sound like I'm talking through a PA system. A slight echo, perhaps 2 audio inputs active. Maybe. Hopefully not. On the OBS stuff, I only have a single audio source selected. Maybe audio input capture mic aux. If that goes down, does that fix anything? Does that change it? There was another like mic aux thing going on. Anyway, oh, cool. Okay, so that was it. It was two microphone things going on. Very cool. Thank you for that suggestion. All right, so let me switch back here. You can look at my pretty face. Hello, everyone. Go back to the arm. Let's look at what we're dealing with. Okay, so we have what looks like we got two screws right here. We'll start by removing those, and they look like just standard Phillips head. We'll start with a size 1 here. Yeah, it seems like it fits well enough. Imagine that there's also going to be some like plastic clips that kind of hold everything in place. Okay. Try not to block the camera here so you can see what I'm doing. Oh yeah, hacker sounds. That's the truth. There's a lot going on here all the time. Yeah. As I figure out audio in this in OBS and streaming in general, my hope is that the hacker sounds will be less distracting. Negative white noise. Nice. By the way, welcome Dio the Destroyer. Happy to have you. So you can see there's a little bit of flex in here. This is probably part of the little clipping mechanisms that hold it all in place. Oh, look at that. So it's got this like this yellow gasket. That's what provides the like IP. What do they call that? the ingress protection, like waterproofing stuff. So this particular one, if I can make that focus, it says IP54, which is just the particular standard of ingress protection against dust and water and things like that. But enough about the gasket. Look at that. We're in. Cool. It looks just like the photos. And we have a few more screws holding those things in place. Also, they are still Phillips head. There's no security torques or anything crazy like that, thankfully. Yeah, and keep in mind, all of this, I'm doing this without having even powered on the device. Something that I'm interested in doing, and I'd love Dio's help with this, is when this thing connects to the internet for the first time, it's probably going to want to pull a firmware update. And by having control over the wireless network, I would like to capture that firmware and potentially do some binary reversing with it. So what I'm trying to do here, we have these other screws that are here. Oh, I think these might actually be for the holding the lens in place. So I'm going to see if I can gently pry this up. Because like there's a little mezzanine board on here, if I remember correctly. Oh yeah. Oh, and the whole thing just pops out. Lickety split. How cool is that? Now I'm trying to fiddle with the speaker there. Nice. So you can see inside we have the little microphone board, and outside we have all of it. So we've got the speaker, we've got the little mezzanine board, the camera, the button, everything. Take out the microphone board here real quick. Done some Wireshark shenanigans. That's cool. Would be awesome if they don't hash check, or if they have weak confirmation that the supply chain is intact. I imagine if you're trying to get some sort of IoT device to market, doing supply chain integrity analysis is not something a boss is going to authorize. They're going to be like, listen, we'll do that later. All right, so little gasket here for that microphone. And this is that microphone board. A little hole in it. And then this. So I have in my possession a cheap HDMI microscope that I happened to forget to bring with me today. So we're going to have to just hold things close to the crappy camera and see what information we can glean from it. I might have to pull some of these things off screen so I can look at the markings on them as well. But now that we have access to this, all right, I'm going to try getting that thing real close. It might not work, so bear with me. Oh, yeah. Look at that autofocus. So good. So, if you can see, this is kind of cool. There's all these like really neat squiggles, and these indicate length matched traces. which generally indicate high-speed signals. And so you can see they're kind of going like into this area here. This would indicate to me that this is what's communicating with the camera. So the camera's sending whatever it's high-speed digital signals along those traces to this processor, which this application processor is what is it, the AC 100. Hold on, let me get my fountain pen all situated here, because everybody needs a fountain pen when they're doing high-tech reverse engineering. Okay, so it's still fuzzy there. AC 100 2B2. AC 100. I'm writing this down in my notebook over here so I have reference. AC 100 2B2. Scooby Dooby 2B2 dash Facebook NV5AP J-2305. Okay, so that 2305, that could be a date code for May 2023, or it could be the 23rd week in 2005. I don't actually know when this thing was manufactured, but that would tell you something about the manufacturing date and potentially a hardware revision if, I don't know, there's a new batch of parts or something like that, which is fairly rare for semiconductors because it's very expensive to spin another rev of silicon. So I'm gonna gently pry apart this mezzanine board. Maybe stick this little guy in here. Also, if I had any respect for circuits and static electricity, I'd be doing this on like an anti-static mat with an anti-static wristband and all those sorts of things. But I like to live dangerously, and hopefully you do too. Okay, so what do we have going on? Same things from the photos. So if you look at U42, I don't know if this thing will work. You see it's an EFM part. This is probably one of the like wireless processors. WinBond. Yeah, it looks like a flash chip. Yep. 8-pin SPI. So we have this guy here, this EFM, I don't know, radio chip maybe. And then these 6 test points. These other 6 test points, I bet they correspond to this guy over here. And then this WinBond flash. What's nice about that, if it's an 8-pin SPI, I have... I don't know if this thing will work for it, but I have some tools off camera here meant for clipping onto and interacting with some of these different ICs on here. I want to check and see, so for this IR LED, it'd be really cool if that was wired for communication. I don't know how I would tell from the traces themselves. You basically want, because you'd probably have like this thing whatever it's, depending how you're switching it, you'd have like the application processor driving a MOSFET or something like that, some sort of transistor, and then that would allow a low voltage, low power I/O pin to power a higher voltage like LED. Very cool. And what's also interesting, so this, the potential 2.4 gigahertz. Oh, okay. The 2.4 gigahertz, what would you call it? RF front end is this thing here, and this is what do they call these? I think it's chip scale. So it's like some bare silicon right here. There's no plastic package around it. So with some powerful optics, we could probably get some good dye photos of that guy there. So you also see, so there's this U5 part. This U5 part, I think, is, what is that? Because so there's this T junction right here that goes to this. This is for a U.FL connector for an external antenna. And this is probably like a diode, or I don't know, maybe it's some sort of RF amplifier. I'm not sure. However, but yeah, it's part of the high-speed RF signal path for this. Sorry, make sure to have these things on screen. Flex. I love that they leave the silkscreen notes on here. It's very nice. The flex inserts on this side. I don't know what that means, but the flex inserts there. Okay, so in that case, let's do this. I would consider this properly disassembled. Ooh, U5's the standard equipment NSA backdoor. Oh, that's right. This is the little exploit that they put on all those super microcomputers that turned out to not exist or whatever. Standard NSA backdoor. Weird, unpopulated flex, but okay. There's so many test points on here, man. I am flabbergasted. What do we even do? So I'm going to go ahead and disconnect the speaker for now, just for ease of manipulation. I can just unplug this guy. Oh, it's in there real good. How do I get this out? Perhaps just brute force. I'll just pull it really hard until something yields. God damn. What's wrong with you? Why are you like this? Is it glued? I mean, like this, like it's got a connector on it, so it should be able to be disconnected, but why is it being so ornery? It might be a locking connector, and I'm just like screwing it up, but why? Anyway, before I break something unnecessarily, put that thing down. Okay, cool. So I'm going to go ahead and I'm going to look up the datasheet real quick. I'm going to switch to my laptop mode, and then instead of the FCC things, leave that open just in case. What I want to do is I want to do a quick Google search here. I'm going to try to find this AC1002 B2 FB. Hey, is that a thing? Disassembling an Amazon blank mini camera. Great. Okay. Ooh, it's a Broadcom part? Interesting. Broadcom Corporation. Manufacturer part number. Can I get a data sheet? All right. Let's see what Astrid Tech has to say about this. So I can't talk about the blankety blankety blank. Cybertruck Challenge. Lots of cool friends. Look at all these things. Just destroyed the thing getting into it. I imagine there's a lot of like similar reused components here. You know, same type of optical sensor, and I imagine similar. Yeah, there's the IR LED. As much design research, design reuse as possible. So this person found on router Reuters. Amazon bought Blink and Imedia for $90 million. Whew. Bunch of weird international sites with ordering pages for the chip. They imply Broadcom makes these. Dropping a few letters off the end. Reviews for a different Blink camera. Door sex swing. Interesting. So the closest I got to a data sheet is this CPU. It seems to be QFN rather than BGA. Quad flat, no lead instead of ball grid array. Plus the performance specs are all completely wrong. And I guess they just went right to the win bond, looking for part numbers there. Wait a second. Wait for the programmer to arrive. Oh, programmer for the Flash? I wonder if... I'm going to see what she's talking about with the programmer here. Oh, yeah. So she'd need a SOIC, small outline integrated circuit clip, which is like what I had. USB programmer, bunch of adapters. Has no on-chip flash and all the firmware is on the ROM. We'll be able to dump the ROM in circuit and no desoldering necessary. It might not be Linux because it's 4 MIBs and that's really small, but at the same time I've seen OpenWrt. Okay, yeah. So it looks like it's pretty difficult. Oh no. To get a proper data sheet for this thing. It's probably something that like so Broadcom and Qualcomm and a lot of these like big old semiconductor companies, they tend to keep all of their data sheets under NDA, and so you won't find a lot of them publicly on the internet. But will he accept the cookie policy? Never. Become ungovernable. Backdoor bell. The name for our DEF CON talk after we hardware hack to disable validation of OTA. You right. That's right, we got that. I'm gonna ring that backdoor bell. Please don't ban me, Twitch. Okay. So now we gotta do a little bit of brainstorming here. So I'm gonna go pull up my face cam so that you can see my beautiful lips moving. Okay, so we have determined that it's some sort of Qualcomm processor on here. Sorry, Broadcom processor. Hard to get the data sheet for. The WinBond Spy Flash probably has the all of the like application code on it. I don't think any of the clips that I have are able to clip directly onto that, which is a good note that I should get some more clippies. I will make a note to myself. Get more chippy clippies. Okay, so with that in mind, we got to figure out a strategy for how to pursue further. A few of the goals that I have for this particular project, beyond just tearing it down, I want to be able to figure out how the code is actually running on this thing. And so, going from unpowered disassembly, we're probably going to need to move into the powered side of things. And with that, we have to figure out, first of all, how to power the device on the bench. We need to figure out what the programming interfaces are. Are there any communication ports? Some of these test points, are they UARTs, like serial ports? Are they talking JTAG, which is a standard for programming and testing integrated circuits? Are they doing anything exotic? Who knows? So what I would like to do to start, laptop, arm. So I would like to start by looking at these guys here. I think that these particular, zoom, enhance, focus. Okay, so this collection here, I'd like to focus on first, and so it looks like it's going to be something like a power, a ground. If it's JTAG, it's going to be like what, TDI, TDO, TMS, something else. I purchased a while back, but have never actually used a really fun, colorful device made by a guy named Joe Grand, who's an OG hacker from way back when, but he's also doing some really cool stuff now. He made this device called the JTagulator, and the way that this thing works is you connect probes either here on these like headers. You see, it's like there's like these different channels, V, adjust, ground. You connect, or you can use these guys here with like little terminal blocks. But you connect these to like arbitrary test points on a board, and this will go through a whole bunch of them, and it will like test them individually, and it will figure out which pins, if any, are JTAG without destroying the board, hopefully. And so that will hopefully then allow us to figure out, all right, once we figure out what the pins are, I have this device. This is called a Black Magic probe, made by, I think it's 1-Bit Squared. Yeah, 1-Bit Squared. And so this is it's a programmer and it's a debugger. It uses OpenOCD and GDB to basically step through the code and get, JTAG access here. Oh man, there's some something going on. It smells like popcorn in here. This is absolutely delicious. Getting hungry. Oh no. Okay. So I guess we got to figure out power. We got to figure out ground, and then I got to connect this thing to a whole bunch of different. Connect it to those 6 test points to see which one's which. And so, if y'all will bear with me, or if you'd like to, follow along with me on your own, I got to dig into some of the documentation for how this JTagulator works. So I know that reading documentation isn't always fun, but we'll make an afternoon out of it, make an evening out of it. So let's go here to the internet. JTagulator. Also, if you'll excuse me for just one moment, I'm going to go grab my gigantic sippy cup of water because my throat is parched. Refreshing. Okay. So, Grand Idea Studio. It's the device of that. On-chip debug interfaces. They can provide chip-level control. TLDR in the JTagulator is that it pops up as a USB serial. Oh, and has a menu-driven UI. That's dope. That saves a lot of time. Get a PC byte kit. Great for probing boards. Cool. Look that up real quick. Man, this is awesome. Retry fail. You got all sorts of good recommendations and comments in here. I appreciate you weighing in on the chat there. Small base plate. Nice. This particular one looks like it holds things in place. Probably multiple things. Oh yeah. Wow. That's really cool. I guess it's like magnets and probes. Dude, that is really cool. Add to cart. Don't want to protect it. Doing it raw. Okay. Cool. Sense Peak. That's also cool. PC byte solution for soldering, inspection, and hands-free measurements. Very interesting. I really like this setup. Oh, cool. And they've got, you solder on these little probes. Cool. I think somebody at SuperCon had something like this. If not this, a very similar setup where it's got these spring-loaded PCB holders. All right. So, if it is a CLI-driven UART, essentially, I'm going to go grab a cable. In this case, oh my gosh, a mini USB, which I hope I have. And I'm going to go ahead and I'm putting the mezzanine board back on. And what else? What else? The microphone board, I don't know if it's not going to want to stay on properly. But I don't think we need the microphone for this thing to function. Okay. So, let's see. My sippy cup is my Mjolnir. Mjolnir. It's true. Only he with proper hydration can wield it. I'll change the screen so you guys can really see. This is a big cup for a big boy. Big hydration. All right. Let's see. I'm going to step away from the microphone so I can breathe, so I can grab my cables. I'll be back in 1 second. Okay. I found a single mini USB. I just want to say that any type of any type of USB port that's not USB-C is wrong. USB-C is the one true port. Back in my day, we had daughter boards and motherboards. It was a simpler time. Mezzanine stayed at the opera. Yeah, you know. I don't know the relationship between these two boards. You know, maybe they're lovers. Maybe they're just friends. In any case, they're together again. We also had master and slave jumpers before they got canceled. Yeah, it's true. People get all persnickety about those terms now, which is a little bit frustrating if, like, you know, you learn one way and it's like, oh, that's how we refer to it, and somebody's referring to it as like something completely different. But, you know, whatever. You like all terminology, it's all relative, I guess. So back here, I'm gonna go ahead and embiggen my font there. So I'm gonna do a dmessage-wh. So of course, the -w, it's an abbreviation for follow, because, you know, there's a W in there somewhere, I'm sure. And H is for human, so for like human readable timestamps. So we got nothing going on. It's just showing you the bottom of the dmessage log there. But when I plug this in, hopefully it'll show us something interesting. All right, so we got it showing up as an FT232R USB UART. Got a serial number. TTY USB 0. Cool. So if we do screen /dev TTY USB 0. That doesn't make any sense to me. Screen is one of these weird modal things. You have to do, like, what is it? Control C Q? Control C question mark? Control B question mark? Control C, Control C? Man screen. How do I get out of here? Oh, Control A. Oh, Control A. Control A. And then, what am I trying to do here? Detach. I'd rather quit, so it's a backslash. Okay. Control A, backslash. Yes. Kill it. Try Tio. What is Tio? TIO. J-Duck, would you mind clarifying what you mean by try TIO? Or try TIO? And actually, do you guys know how to specify the baud rate for screen? Oh man, we got some power tools going on. Cool. All right. I like simple serial device I/O. I'm gonna see if it's in the AUR. Lib serial port, minicom. Nope. Where you at? Let's watch Patrick install software. Yay. Okay. Plays nicely with Tmux. That's nice. I like Tmux. It was created to replace screen. Features, usage, key commands, installation. Oh. Go back to usage. Oh, cool. Gets to build it from sauce. Okay. So, TO list devices. Hey! It works. All right. TO-B for baud. Okay. 115, 200. Oh, that's the default. Okay. Well, let's try it. It's gonna be like, yo, oh. What's up? We have some sort of a shell. Help. Question mark. Exclamation mark. What do we do now? Additional resource documentation. Yes. Check out the wiki. Command set. Okay, cool. So we got some general commands going on. H. This is firmware 1.10 support. Go to the manufacturer of the chip on here for any support of this board. Joe does not support these. Okay. So in that case, if we switch back over here, so we have this guy. We know that if we take our, it's meant to run off batteries, right? This thing is meant to run off of like 3 volts. So I wonder then if we can just apply 3.3 volts to it, or 3 volts, on these like battery terminals, and if that will power up the device for us. Unfortunately, I don't have. I think this like particular layout here. I think there's certain like spring-loaded programmers that will like just kind of sit on there. I do not have those spring-loaded programmers, and so I think I'm going to have to maybe solder some jumper wires onto these guys here, break them out. That'll make things a little easier to work with, but a little bit more difficult to package up. So let me go get my soldering kit, and we can go from there. Jugs and HIV? What? I don't know what distro it is. I think I used it on Ubuntu. Yeah, I'm running Arch, by the way. All right, so I got some jumpers, found these things, and I might need more jumpers. And I got my my 3D printed pine sill. Look at that thing. I gotta say, the advent of USB-C powered soldering irons is like the best thing that's ever happened to hardware hackers. Yeah. Hey, no worries, man.
I'll wait until you finish so I can get the other part.
Yeah, go for it. Yeah. It's part of the ambiance of the stream.
Sorry,
no worries, man. You're good. Yeah, that was the guy doing power tools. He's working on the one of the TARDISes that they have in at Circuit Launch. That's they have like TARDISes scattered throughout the space that are used for like video conferencing or whatever. Pretty cool. Um, da 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 da. You know, I gotta say, like, no matter how much space I have, I always don't. I always run out of it. I manage to just fill it up with a little bit of everything. All right. I'm gonna zoom out. Oh, you get a better view here. Let's see. What can I unplug? Okay, so I'm gonna go on battery for my laptop here, and just use this. You know what? I realized I have a soldering iron. I don't have any solder. However, I'm gonna go out to this hack space here and see if I can grab some. So, pardon me. I'll be right back. Point it out. I'll turn this light off so that you guys can see what's going on out here. All you see is a big old ring light. Okay. So I'm gonna go somewhere around there, see if I can find myself some solder. BRB.
Well, so the idea is you have the little camera facing on wall tools. Right? You do image differencing, motion detection, image differencing, and basically the way I've got it set up is so when somebody comes into the frame, it makes note of the time, and then once they leave the frame, it does an image difference of the wall and see if anything's missing. And if it does, it takes the next block, marks it, and then reports it along with two pictures, one of the tool missing and one of the last person that came into the frame. And then it takes those images and puts it off the SD card. And that I think was the problem. What I was having trouble with.
Taking apart a doorbell and attaching some debugging to it right now. You post the link to that.
Because no one's going to walk in. Yeah. Yeah, I don't do facial recognition, so I don't need. I can probably on most people's profile. Most people's profile. The real problem is the state of
Okay, I'm back. Got myself one of these like tip cleaners for the soldering iron, as well as good old leaded solder. It is a little bit tastier, but a little more dangerous than the unleaded stuff. Okay. Und now we wait for it to heat up. Yes. Yeah, dude, this place is huge. Let me put a link to it. It's called Circuit Launch in Oakland, California. Oh yeah, flux fumes. Alright. Got this little stand here. Alright. Let me quickly do this. Circuit launch. So this is the website for Circuit Launch. If you guys want to check it out. Oh. Which, by the way, where are you guys located? I know where Dio is. Single rider. I'm not sure exactly where you are geographically at this point. You move around a lot. Okay, so doing the make sure we can watch the snipping happen. The snippening. Okay. So we got some of these guys, some of those guys. Okay, so now that the tip is hot, I'm trying not to burn myself or anything else around here. Give it a little cleaner-rooney. Got this little guy. I'll give it a, woo. This might be a little too hot. That's some aggressive smoke there. Yeah, I'll put it at like, 375C. Even that's probably too much, but better than what it was. Okay. So, put these things on frame. Wonderful. And honestly, it looks like this stuff is solid conductor. Which it may be. Maybe I'm just not looking carefully enough, but in any case, we want it to be acting as if it's a solid conductor. So, and now what I'm doing is I'm trimming it so that it's just about the size of the pad. So that way we can try our best to minimize shorts because we don't want it bridging onto other contacts and blowing stuff up potentially. Okay, so we got 2. Now we want 2 more. Never forget Stock image fail. Soldering. I don't even need to click on that link. I know exactly what it is. I wonder with all of these like generative AIs that are based off of stock images, if like what is the actual likelihood of something like Dolly or I don't know Stable Diffusion, like if you say like a person soldering and they show it like holding the iron like that. So I imagine that's a pretty I don't know popular soldering iron image, and might have a statistically significant reduplication in like training data sets or whatever. All right, so we're trimming these things down. Trying to do that. All right, so we got, crap. We have 2 yellows. You know what? We're just gonna have to deal with it. Okay. Doing the thing. Oops, I dropped some of those leads. Also, Dio, I am certain that you will recognize these jumper wires from SuperCon. These are little freebies. I'm not sure if any of the other folks in the chat have had an opportunity to go to the Hackaday SuperCon. But it's a conference in Pasadena, and I went with Dio, my roommate, and a couple others, and we did some hardware hacking. It was pretty fun. What's kind of cool about those conferences is like you can't do it all, but you can kind of find yourself in different kind of tracts, and the entry badge is like a project in and of itself. What? Come on. Are you broken? Are you dead? Why you no melt my solder? I don't feel its touch. What have you done? No, don't sleep. Turn on. Yeah, so like the badge, it's a project. It's a circuit board, and there's all sorts of like ways that you can hack it and stuff like that. And there's people that go to SuperCon and they flat out refuse to do any badge hacking because they're like, yo, if I start doing any badge hacking, I will not stop, and I want to be here for the socializing aspects instead of the badge hacking aspects. And then for the folks that don't want to socialize, you can spend literally the entire time just hacking on your badge with whatever dozens or I don't know, maybe even hundreds of people, just taking things apart, adding things, getting into the software, getting into the hardware. It's a pretty cool experience. And then people give a bunch of really interesting talks as well. But those end up online, and so I generally recommend to people that have never been, like, try to focus on the experiences that you can't look up on YouTube later. Ah. Oh God. Managed to kick my soldering iron off of the table there. Ooh, that smells like burnt plastic. from the carpet. Whoopsies. It's only a little bit toasted. Ugh. Oh, sorry, I gotta do some texting. Do. Let's see. So what? It's 6:30 right now. I'm probably gonna stream for about another hour or so. We'll see where we can get to with that, but I think that'll be enough time to at least figure out if we can get a shell over JTAG. Okay. Accept invite. Ba-da-ba-ba. Okay, so let me get these last jumper wires here, and I'm using these guys because I don't actually want to use the duplicated yellows. I know for certain that if I have duplicated colors on here, I'm going to screw something up and end up confusing the two. Fume extractor would be really nice in this situation. I gotta make sure I add that to the list of things to bring, in addition to my microscope and chippy clippies. Microscope. I might try to do this stream, or do future streams, just right in the electronics lab there, where I got the solder and such from. There's probably going to be a bunch of people still talking and interacting and stuff like that, but maybe that's okay for certain purposes. Okay, so let's go ahead and get that camera all up in there. Yeah, just like that. Ba-da-ba-ba-ba-ba-ba. Even closer. So close. All right. So here's what I'm doing. I'm going to use my super duper soldering skills to basically put a little blob of solder in on top of each one of these little test points. If I can. If I had flux, that would make my life a little easier. which I do. I don't want to go get it. That one might be the ground. If they're tricky to solder, it might be because it's wicking away too much heat too quickly. Yeah, okay. So that one that I touched is probably connected to ground. So I'm putting these little blobs on here. And that'll make it easier to attach the tinned wires to it. Making sure they're nice little round things. Whoop. Making sure that we're not putting any extra solder where it doesn't belong. And according to some, solder doesn't belong here in the first place, but you know what? We're not listening to them. I'm going to go ahead and do our own thing. Okay, so, nice. Let's go ahead and get these things hooked up. This would actually be easier to see and probably more interesting to watch with the microscope. They have a really nice stereo microscope over there. I don't know if it's trinocular though. The trinocular ones are cool because you can like put a camera on them. But that's gonna be my some of my wish list items is getting a trinocular scope. Is the getting the extra depth perception with like a binocular scope, super nice. There was a scope that I used at a job that I had. I forget what they called it. It was like some aggressive insect name. It was like a scorpion or attack spider or something like that. But it was a really cool like stereo microscope that didn't have like eyepieces. It was basically like a pane of glass, but it somehow focused two lenses into your eyes in such a way that like you could get that same sort of depth perception, but you didn't have to like put your face like right up against it. Super cool. Okay, so we got 2 wires in there, doing the third. Actually, you know what? I'm going to put these in here like so. Oops. Make sure we can see what's going on here. Yeah, so we'll put these at a little bit of an angle. And then this one's going to be at the opposing angle. Well, it's on there, but not on there real well. I don't know. Perfect is the enemy of good, as they say, but man, I want these little joints to be perfect. In defense of perfect solder joints, if you have nice joints, all the ladies would be like, hey, nice joints. But also, they'll stick on here a little bit better. And if you do some wriggling with them, they're not going to fly off as easily, you know. So just making sure that they're good and secure, you know. Not that one. So there's a black and a white wire going on here. That is not to imply that it is power and ground. They are merely just colors in the palette of stuff I had in my box. Cool. On the final one. Ah! Look at that. Can you believe it? Oh, shoot. Almost lost it. Let's see if we can get a real good close-up. I don't know about you, but those are some good joints. Okay. So we got those things, doing those things. Separating out these wires here. Just to get a read on the folks in this room. Well, we're done. Let's submit the CVE. That's right. Essentially, if you can get JTAG access to a device, like you have essentially achieved root for the most part, or rather, it is often trivial to get root after that. So I don't know about a CVE. It's like, yeah, we know this is a problem, and then just dismiss it. But okay, now comes the next stage in this process. Now I gotta get. Excuse me. Oh God, dropping batteries. Gotta get this thing powered somehow. If I were a betting man, and I am, I would bet that one of those pins is ground. So the way that I'm going to test that is I'm going to get my handy dandy fluke beepometer. I guess it has some other functions, but seriously, like 90% of the time, I just use the little beeping function where it goes like beep 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 beep. So amazing. It's a continuity tester. I prefer beepometer. It sounds more sophisticated. So if I touch here and I touch one of these, hey. So this guy here is connected to this guy here. Perhaps white is ground. What did I say was ground as well? Something. One of these test points. So we essentially want to find something that is connected to like essentially the larger, like large planes of copper. Not generally indicates that it's ground. But actually, if I look at this thing here, flip it over. Yeah. Let's see. Zoom, enhance. All right. So if you look here, you might be able to see this one. Okay. This is the battery terminal. This is connected. It's connected to Q9, and it's got this little like island around it. This makes me think that this is a this is the positive pin, because this one over here, looking at it, it's like looks like it's directly connected to like all this area around here, all around there, and so like I don't know. You look at something that's on here. Oftentimes you have ground in like these little pads here. Hey, what do you know? So this is the ground pin, which means that this white wire is the ground pin. So just to confirm, this is the white wire from my test point hookup thingamathing. Oh no, it doesn't work anymore. Why doesn't it work anymore? What happened? Did I goof up? I might have goofed up. Oh crap, there's two white wires. Oh no. Okay, well, this white wire is ground. So a wiser man would have labels so that he can properly annotate what's going on here. Oh yeah, try the other white wire. Yup. Yeah, dude, that fluke beep, it's the best beep. Pay premium for that beep. Okay, so we got white next to what? White, I will call it white parentheses purple. Ugh. Ground. And how would I identify that guy? J10. J10 bat contact. Okay. Onsen. So if that is the case, that means this thing can hook directly to ground on the J-Tagalator. But actually, I'm going to do some more labeling before I plug things in. Not an issue to plug something into ground, but still, I want to make sure that I'm not getting ahead of myself with this thing. I wonder if that's the only thing that I really care about as far as the J-Tagalator is concerned. So, oh, you know what? Here I go probing everything. But if I just thought for a moment how these batteries fit in here, they go in like that, and it's like, yeah, the negative end of the battery goes against that contact. Doi. But hey, we derive the answer from first principles. Always a valuable exercise. Now, how am I going to hook up the batteries to it? So we got this thing. This is the actual battery holder. Sits on it like this. What I'm trying to do, maybe, because inside of here, there's a conductor that is, it's shorting these things out. So, you have the negative terminal, connects here, shorts to that thing, and then that goes to the, whatever, the positive terminal. I wonder if these things, it would be real cool if these things were somehow, no, that's not going to work, because you can see it's just plastic in there. It relies on the metal pieces coming up here. I don't have a power supply. Actually, grouping that was exposed. Was this the grouping that was exposed with the case on? Yes, it was. So these guys, so this group over here, they were not exposed with the case on. I believe that this grouping goes to this processor here. Or maybe, I don't know, maybe it's that little guy, that U43. But yeah, I think it's for the main application processor. How can I? Let me go. I gotta go rummage through my stuff real quick, see if I can find some clips and try to figure out a way to make this work. Actually, let's see. If I put this in like so. Oh. We're at 2. Wait a second. Here's what I can do. Because we've got a hole right there for the test points. I might be able to feed these things through and just kind of do a little janky-do thing here. If we do that, and assuming my solder joints are robust enough with respect to something or the other, with respect to jiggling, I might be able to just put that on there and feed the battery contacts back into the original case. And if we do that, then I don't need to finagle anything more complicated than that. This might put a lot of stress on these test points. Forgive me, dear test points. I only hurt you because I love you. How does that go? Is that just kind of sliding on in there, huh? Oh. The battery is going to interfere with that. Gee dang it. Yeah, you're right, J-Duck. Doing the little battery carrier would be the right thing. I just don't have one right in my vicinity. Okay. What if I did, instead of pushing those through there, what if we just, oh God, now that I've already bent them, let's bend them back. Oh, and fatigue them as much as we can. All right, so I'm going to put the battery case back on, but just push it over the top of these things as they're laying down. Not trying to, okay. So we're going to do this. We're going to take this thing, and we're just going to put that down on top of it, like so. Voila, that might work well enough to power it at least. Cool, okay. Let's do this. Please don't blow up or do anything crazy. All right, it's blinking. This is blinking red. Look at that. Oh, well, it was. Oh, you see, we're blinking. Bleep, 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 bleep. Great. All right, so in that case, so white, purple. We're going to go to ground here. And now, going to change scenes. We'll go back to laptop over here. Okay, so here we are back in this UI, but I'm going to pull up JTagulator. Oh, I wonder if it's important to have this daughter card / mezzanine connector thing on here. Oh, poo. How do we do this? Because this thing, it looks like it has a lot of power regulation stuff in it. Maybe battery charging and all that. So maybe it's a good thing to have. So, all right, so I'm hooking that thing back up. We'll go ahead and repeat this process. Just kind of put that down on top. Put that in. And then put that in. Okay, we got blinking red lights again still. Hopefully that's not yelling about like, oh no, low power or something. Okay, so if we can just, it's TO, command set, okay. Target interfaces and general commands. So we're looking here for JTAG commands. We're going to identify JTAG pinout. Pin mapper, X-test scan, instruction, discovery, get device IDs. So identify. Okay, so I guess we'll plug this up and just press J. Okay, let's put the other white one in. What's that? Channel 6. Okay, the yellow. It's channel 7. Green. Into channel 9. Do black. Channel 21. And then purple. Channel 23. Okay. So we go back to our terminal here. Doesn't know what's going on. We hit J. JTAG. J for JTAG. Did you do it? So we hit J for JTAG, and then we're in JTAG, and then I press J again. Target I/O voltage must be defined. V for voltage? What do we think the target I/O voltage is, guys? Probably 3.3, but who's to say? Well, can't be anything more than 3 volts. I'm not worried about it being too not worried about guessing the voltage being too high. Sorry, not worried about it being too low. I don't want it to be like a 1.8 volt thing and then end up blowing it up. However, this win bond part, we know the datasheet for it. We can go back to Astrid's page. Where's Astrid? Astrid.tech. Okay. So we go down here. So she did find a data sheet for the win bond. I'm going to assume it's the same. Oh, wow. That's a 1.8 volt. I'm very glad I checked. I could have destroyed this. .8. Ensure V-adjust is not connected to the target. I am certain it is not. All right, do something fun. Enter starting channel. I guess channel 6. Channel 6 is the start. The ending channel is... Wait, is it 6? No, that's 16. Oh, well. To 23. Bring channels low. Bring channels low between each permutation. I don't know what that does. Or why you do that. We must always hack the ones we love. It's true. Let's see. I'm going to go back here to the command set. I think I'm just going to say defaults. Don't do anything. Press the space bar to begin. Are you guys ready for this? I'm not going to wait for you to say yes or no. We're doing it. Woo! We are JTagulating. It looks like it's taken a while. I wonder if it's because it has to go through 6 through 15. It's testing, but it's doesn't need to. Aww. Come on. Okay. It's 16 to 23. Bring channels low. I guess we'll do it this time. Enter the length of time for channels to remain low. I guess 100 milliseconds is fine. The length of time after channels return high before proceeding. 100 milliseconds. Why not? Let's try this again. JTagulating. I wonder if the voltage on these batteries is too low. Actually, it's taking longer than it was previously. Oh, right, because I'm putting in a whole bunch of delays between each permutation. So there's 1,680 different combinations that it gets to try. But it's less than the 73,000 that it ran through previously. So I wonder if that's why bring channels low between each permutation. I wonder if the reason why it's no by default is because it just adds a bunch of extra time and it might not be necessary. No target devices found. That's a bummer. Okay. So you can't like do backspace, it seems. So this isn't as immediately gratifying as I would have hoped. It's blinking. I guess in this case, I'm going to switch scenes here back to the arm. So we can see it's blinking. Very possible that blinking means, battery's too low to do anything useful. I do want to probe this guy here, the wing bond flash chip. Ooh, actually, I remember looking on this thing and I was like, yo, those are probably the ground and power. Mm-hmm. Ooh, there's 3.3 volts going to the microphone. Interesting. Any capacitors on this guy? So okay, so we're probing here. Wait a second. Why am I not reading anything anymore? Anyway, let me put this under here so you guys can see this too. That way you can see the readings. Okay, so if this is supposed to be positive, this is supposed to be negative, that says 3.2 volts, okay, going into this thing. Got 3.2 volts. This is ground. Okay, one of these. There it is. Okay, that shows 3.2 volts. So basically VBAT. Okay. Now, I'm going to switch probes real quick because I have these other probes. These probes are so cool. They have special, point protectors on them. They're like ultra sharp, mess you up type probes if you don't know what you're doing, which I don't most of the time. And so these probes have messed me up. So I'm just going to use this one because I have for the negative probe, I'd love to just attach that to the battery. And so I have this cool little clip. And if I can, maybe I'll clip it to the battery. Somehow. Just give me something to clip on. I guess we can do ground over here maybe. And just clip it to the just clip it to the USB port of the G-tagulator. Let's see if that works. Okay, we getting voltage. We doing the thing? Huh? No. That is not doing the thing. Okay, I'll get the probe. Just hold it like a peasant. let's get in here. So we want, that's positive. We want this one here. You know what? Where that wind bond at? Where's your pin description? No, don't describe your pins to me. There it is. Okay. So VCC and ground, they put them oftentimes for these sorts of packages at opposing ends. So it says that, so if this is pin 1 here, pin 1 there, that would be pin 8 VCC, and then ground is over there. Okay, I might have to get my face in here real close, but it's got a capacitor there, which is a good sign too. Okay, yeah, so that is a 1.8 volt wind bond chip. So if it's 1.8 volts to the SPY flash, but it's 3 volts to the microphone, what a conundrum. What are some other ways that we can figure this out? We can find some, so X, that's a crystal. I'm wondering if we can probe some of these capacitors around here. They might tell us what the voltage is, because, you know, it would be awesome if we could just say, oh yeah, it's a 3.3 volt part and away we go. But I don't want to risk that until I know for sure, because this certainly is not a 3.3 volt part. This is 1.8 volts. What to do? Maybe it's not JTAG. Yeah, that is a very real possibility. It could be a UART. It could be anything really. The next step after fiddling with this is going to be actually oh cool, the JTagulator can actually do UART as well. I did not know that. So you can do SWD as well, which, wait a second, SWD, it might be that too. So let me try a couple of these other things then, because we're already at 1.8 volts. We're already connected all these sorts of things, and yeah, it's worth a shot. So I'm going to see if we can do, how do we back out of here? So we're going to do H. We're going to see what's going on. We're in the JTAG area, the JTAG command mode. Main menu. Then I is going to get us to nothing. No. So S for SWD. Okay, and then I for checking that out. So we got, 16 through 23 again. We will bring the channels low. Okay. Let's get to JTagulating. I'll switch over here so we can see. So it says ID code scan complete. No target device found. What about a UART? We want to do U for UART, and we want to say U for
And then my friend did it to Natalie, and then I ended up doing it to
are any pins already known? Nope, I know nothing. Enter text string to output. Prefix with /x for hex. Carriage return, I guess. Enter the delay, yada yada yada. Ignore non-printable characters. No. Do it. Do something cool.
the stove.
Oh, they put it on this, oh, they put it on the real stove.
They put the stove down the stove. I know. My friend's mom, she's been forgetting to turn off the stove. So my friend's like, okay, to solve the problem, I'm going to get an induction stove with a timer and have it mom down. But the kitchen's kind of small, so limited space. So just put this on top of the real stove, and the mom.
So interesting. Waiting for it to JTAG.
But I'm still, because he was looking for stuff for marketplace, and I told him, like, for like mission fair,
No target devices found. Ugh.
Did she actually cook with that?
Okay. So, we went through JTAG, UART, and serial wire debug. Did not yield anything interesting in terms of exposing the interfaces for us. This is a BGA part, so we can't probe any of the pins directly. Let's see. We'll try some other stuff here. So I'm going to switch back to the ARM. So I'm going to see if I can't. So this is a crystal here. It has nice big pads. And I know that it's supposed to be a clock signal, but maybe it has a VCC going to it. One can hope, one can dream. Come on. I want to see that red blinky blink. Okay.
There was no thermal fuse in that little thing?
Okay, so we have that 0.8 volts. Okay. Not helpful. What if I unplugged everything? Ha 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 ha. And we got our known ground here. This is sacrilege to do to a really nice probe. Never do this. Okay. I'm going to do that. I'm going to poke and prod these things to see if I can't... To see if I can't... Sorry, I'm forgetting to narrate what I'm doing here. What I'm going to do is see if there's any voltage that's showing up on the... any of these potential pins here. Because if that's known ground, okay, then maybe one of these is going to be like, oh, hey, look at that. That's 1.8 volts. And then another one doing nothing. That's doing nothing. Doing nothing. But that's 3 volts. What is happening? Is one VBAT and the other one's like VREG? This sucks. Why are you like this? Alright, I'm gonna get my face real close here. I gotta move the microphone. This is 0.8. This is 0.8. That says 3.3. That says 1.8. Sorry, I'm late to the party. How's it going? Well, it's going. So I have some wires here that are attached to test points on the other side of the board, and I'm trying to figure out if it's JTAG and if I can connect to it and all that kind of stuff. Looked up the ICs. Yeah, so did that a little bit earlier. I was looking at the FCC documentation and also trying to Google it. This particular IC on here is it's a Broadcom part, and there isn't a lot out there on what's going on. I think there might be multiple ARM cortices, I guess. This particular chip, what's weird about it, right, is like, so this is a 1.8 volt like SPI flash. However, this connector here is for a microphone that's 3.3 volts. So I'm the JTAGulator. One of the cool things it does is you can search, or you can like use it to discover both JTAG as well as SWD, and you can also it can do UART discovery. So I tried all of those things at 1.8 volts. Proprietary immediate processor. Awesome. Yeah, so probably not going to find much, but yeah, if there is anything out there, I'd love to know more. Yeah, UART, if there's a UART. I don't know. There's so many test points on this thing. I might just have to, I don't know, break all of them out and plug them all into the JTAGulator. What's making this challenging, right, is that, yeah, so will using 3.3 volts damage it if it's 1.8 volts? That's what I think is the case. If it's only 1.8 volts and it just happens to be like, I don't know, 3.3 volt tolerant, then that means we could do that on the JTAG pins, potentially. I don't know. The tolerance. Yeah. So, yeah, I really want to figure out definitively for this particular part, like if it's 1.8 volts or if it's 3. Well, I have another one of these blink doorbells. So if I do break this one, I have another one that I can try with, but I'd really prefer not to if it's possible.
You know, it's always just easier. I mean, unless you really need to do ETG, and then I think once you start working with those, you just need to use yeah, you just have to like actually
Yeah, I don't know.
and calibrate
Hmm. Oh, the FCC link. Yeah, let me put that up here. I think it's open in one of these tabs. So the here we go. FCC.gov. Did I close that? Yeah. Let's see. FCC. Get attachment. Dot. List exhibits report. Get application attachment. Okay. So we can look this up again. FCC.io. And then put that string in there. Okay, here we go. Yeah, the pictures are pretty bad. You can't see any of the IC part indicators or any of that type of stuff on there. What I do is find the data sheet or similar data sheet, and then I'd use the pinout for an approximate area to look for specific test points, caps, resistors. Dang it. What the heck? Stand by. Let me figure this janky stuff out again. Ugh. Sorry about that. So just for completeness sake, that's the FCC ID right there. And so I'm going to fcc.io and just putting that in. See if that works. All right, see if that works. I don't know if that link will be any better or worse. Broadcom. All right, so now let me switch away from. I'm going to switch away from probing for a moment here. And try to do some OSINT. See if we can find some information about this thing. Because, like, all I need is a input voltage. So it's this AC 1002B2-FB. All it pulls up is stuff talking about how it's unavailable. There's no data sheets. So we know that Broadcom makes it. Actually, how do I do that with searching by file type. Yada yada. All results. We want. What is it? File type. U. File type PDF.
Current build plate is not the same as the G code. Do you use the PEI code? Or the cool plate? I'll use the cool plate.
Interesting.
Let's use the cool.
Let's just go clicking sketchy links everywhere. See if we can't get ourselves hacked in the process. I don't know if any of you guys speak Mandarin, but I know that for some of these obscure parts or things that don't have good data sheets off of like English search engines, sometimes Baidu has stuff. So I'm gonna try there. I don't really speak that much Mandarin, but
Yeah, you gotta watch that because if you.
they might have some stuff.
No,
Gimme.
It's great. If you set the wrong one, it tells you you can't do it.
BGA Broadcom.
In the sky, in the
First result.
the slicer though,
Uh,
auto select. You choose. It usually always starts.
do this. Translate. Where to find the chip wholesale.
I think the
Blink.
on that is a better PEI, and they have
Oh.
that come with the other with that gold. It's always the same.
Smart access point.
It works. All the build and stuff, tuning and everything all works.
Hmm.
The technical PEI when it's gold. The cool plate. So they really only
Man,
set the cool plate
it's like there's so much like cool stuff available, like in the like Chinese language internet. But I just like I can't access any of it because I don't understand the Mandarin. I don't know how to navigate it properly. Also, like a lot of things they require like Chinese phone numbers, like QQ phone numbers to operate, and to buy stuff as well. I don't know what it's saying. It's got this part, but it's just showing other parts going on here. Broadcom, BGA.
Which one would I get? I mean, definitely the P1X.
What does it say? 8.5 volts. So maximum supply voltage, minimum supply voltage. Anywhere between 1.5 and 8.5 volts. We know this. We've measured. It's either 1.8 or 3.3. Oops. Yeah, that's not super useful. Disabled somehow. Yeah. So I'm guessing it's 1.8 volts, but just disabled somehow. If the microphone is actually, I want to see if that wind bond part, if it's 3.3 volt tolerant. Because even if it's 1.8 volts, I wonder if it can. I wonder if it's getting like on its data lines 3.3. I really want it to be 3.3 volts, but can't make it be something it isn't. General description. The device operates with 1.8 volt power supply.
But I know legally, if I'm on the sidewalk, as long as I'm, like, I can't go past 3 miles an hour. But with 3 miles an hour, that's fine. Well, we need to,
Looking for absolute maximum ratings. So if we say it's voltage applied to any pin relative to ground, if VCC is 1.8, okay. VCC plus 0.4 is 2.2. So 3.3 volts on any of those pins would explode it. Or at least, cause it to operate outside of its absolute maximum rating. Transient voltage. Yeah. I think you're right. I think it is probably 1.8 volts. I don't understand, though, what's going on with the microphone, because the microphone has 3.3 volts going to it. I don't know if it's like going through like a Zener diode or something before it goes into the like I/O pin. But it's confusing. Very confusing. Okay. So maybe that's just a disabled port. Okay. Ugh. All right. So it's 7:40 my time. I think I'm probably gonna wrap this up and start putting things away. But we have some good starting points for next time and some good opportunity for exploration. I think as well, if I get like a little chip clip, something that can attach to the Spy Flash, I might be able to just read it directly and not have to worry about trying to interface with it. We can at least get the firmware off of it. But yeah. All right. Well, friends, thank you so much. I really appreciate you guys weighing in on the chat. This has been super helpful and really nice insights from all of you guys on the guys in the chat there. Yeah. If you guys like, I don't know. I don't know how I can notify you guys in the future, but yeah. So thanks, Xenoflex. Yeah, thanks, Dio. And yeah, I'll see you guys next time. Let me see.